Define and use properly in context all new terminology. To include confounding variable. So what is a confounding variable? It is a variable that affects another two variables that are considered for examination. So for example, we could have a study that suggests that the use of sunscreen causes skin cancer. Well, would you really think that sunscreen causes skin cancer, or there's some other variable that we're not considering? Perhaps there's a confounding variable that affects both the use of sunscreen and skin cancer, and that is sun exposure. Because if you think about it, people that are more exposed to the sun are more likely to use sunscreen, but they're also more likely to have skin cancer. So this is an example of a confounding variable. And so what is the definition of a confounding variable? It is a variable that is correlated with both explanatory and response variables. Prospective study. Now, a prospective study is a study that focuses on the present and on, so gathers data as the events unfold. A retrospective study is a study that gathers data for observation after the events of interest have occurred. Now, what is simple random sampling? It is a way of sampling that consists of considering the whole population of interest for a particular survey or observational study, and a selection that is random, in which each case or observational unit has an equal chance of being chosen for examination, and the presence of one case or observational unit is not in any way related to the presence of another case or observational unit in the sample. Now, what is stratified sampling? Now, stratified sampling is a little bit different. In stratified sampling, we take the whole population and we divide it into strata, which are subsets that are different within each other. So, sorry, not within each other. They're different from one another, and within each other, they're similar. For example, a case of this would be, let's go to USAFA and let's divide the whole cadet population into majors. If we divide the whole cadet population into majors, each group, each strata is similar within itself because they all have the same types of majors, but within between each other, so major, management major, or biology major, or aero major, they're different, right? So that's how we would define strata, and then we would use simple random sampling within each of these strata to choose the observational units that will be examined for each of the strata. Now, why is that good? It could be good because at that point, we would ensure to have a representative response, because we can randomly have the chance that we only sample individuals from particular groups, and that would not be representative of the whole population of interest, which would result in a skewing of the results from the true value. Now, let's talk about cluster sampling. Now, cluster sampling is a sampling method that divides the population into groups, but these groups are all similar among one another and diverse within each. So for example, if we keep USAFA as an analogy, we can say squadrons. Squadrons have a mix of everything. They have a mix of firsties, second degree, 4th degree, and 4th degrees. And also, they have a mix of different majors. They have a mix of a lot of different things, of ICs, of airmanship people, of people that like to do other clubs, all these things. And then within each strata, what do? We pick certain, not within each strata, within each cluster, at this point we're calling cluster, we pick only certain clusters with simple random sampling to actually analyze. So that's the difference between these three. Now there's another one that you should remember, which is multi-stage sampling. Now let's talk about multi-stage sampling. This is the one that I always get a little bit confused about. So I probably need to go ahead and review it. So I'm pulling out the book for this one. And let me just see where this one is. It should be, we got the 3 sampling methods. Okay. Multi-stage sampling is similar to cluster sampling, except that we take a simple random sample within each selected cluster. For instance, if we sampled a neighborhood using cluster sampling, we will next sample a subset of homes within each selected neighborhood if we were using multi-stage sampling. So it is a sampling within a sampling. So from my understanding, what multi-stage sampling is, once we have a cluster, we would generate a subset. We would sample not the whole cluster, but a subset of this cluster. Okay, that's called multi-stage sampling. All right, now let's go back and see what else we have here. An experiment. So an experiment is a study in which the experimenters control the environment, have a treatment group and a control group to exclude the influence of anything other than the variable of investigation. What is a randomized experiment? So these are the principles of the experiments. It's when researchers randomize patients between the treatment group and the control group to account for differences that they cannot control. And so let me underline certain ones. We could say a randomized experiment and an experiment. These are two that need a little bit more attention. Control is a group in which, it's a definition. Control is the difference between the treatment group and the control groups are minimized. Let me just pull out here the book as well. So researchers assign treatments to cases and they do their best to control any other differences in the group. For example, when patients take a drug in pill form, some patients take the pill with only a sip of water, while others may take it with an entire glass of water. To control for the effect of water consumption, a doctor may ask all patients to drink a 12-ounce glass of water with the pill. So they do their best to control any difference between the treatment and the control group. Then we have the idea of randomization, which is randomized experiment. Researchers randomize patients into treatment groups to account for variables that cannot be controlled. For example, some patients may be more susceptible to a disease than others due to their dietary habits. Randomizing patients into the treatment and the control group helps even out such differences, and it also prevents accidental bias from entering the study. So that's the idea of randomization. So we can control what we can control, we randomize what we cannot control. Replicate and blocking, let's see about. So replicate, the more cases the researchers observe, the more accurately they can estimate the effect of the explanatory variable on the response. In a single study, we replicate by collecting a sufficiently large sample. Additionally, a group of scientists may replicate an entire study to verify an earlier finding. You replicate to the level of variability you want to estimate. For example, in flight test, we can run the same flight conditions again to get a replicate. However, if the same plane and pilot are being used, the replicate is not getting the pilot-to-pilot or the plane-to-plane variability. So, you can replicate to the level of variability that you want to estimate. But for an experiment to be repeatable, that's really important, and it is a direct result of the amount of observations that you have collected. Okay? And then we have another definition, which is blocking. And we haven't really talked about blocks. But what is blocking? Well, blocking, researchers sometimes know or suspect that variables other than the treatment influence the response. And under these circumstances, they may first group individuals based on this variable and then randomize cases within each block or group to the treatments, which is called blocking. So it's a technique to avoid known variables to influence the treatment, and they generally do so. Researchers, that's not an R, apply this technique, oh, I don't know how to spell this. This is not right, sorry. Technique, I think this is how you spell it. Let me just double check real quick. I don't want to give you false information. I'm missing an H. Technique. Sorry. Technique. So, the researchers apply this technique by first grouping based on a variable that they suspect might influence the results. Might influence the result. Then they choose the treatment and the control group from each of these groups. From each of these, groups, or from each of these. All right, so what else? We talked about blocking. Blocks, that's what these groups are called. Treatment group is a group that actually gets the treatment. A control group is a group that does not get the actual treatment, might get a placebo. And that's because we want to see if the treatment actually is the cause of certain changes in the status of the cases, observational units, or patients, if we're talking about people. Now, what is a blinded study? A blinded study is a study in which the patients do not know whether they are in the control group or in the treatment group. We talked about what the placebo is, and the placebo effect, you might think that the placebo effect is just psychological, but it's not. For example, if you have a particular treatment for something, you may be more optimistic, and that would be a psychological component, but you may also be more cautious with your diet or with your sleep or with your exercising, and that would affect the results. And so we don't want that to happen, but you may not even get the treatment, but if you do these things, you might be a little bit better off, and that would be the placebo effect if you think that you are actually getting the treatment. And then a double blind is where the people that are administering the treatment don't know whether they are or not, and the people that are receiving it don't know whether they are receiving it or not. Given a study description, be able to describe the study using correct terminology. Given a scenario, describe flaws in reasoning and propose study and sampling designs. This is probably one of the most difficult objectives so far. Well, I hope this was a useful review, and we'll keep going with the chapter 4 in the next video.